Company takes out loan 15 million, annual effective discount rate 5.5%. The loan is to be repaid with n annual payments of 1.2 million plus a drop payment 1 year after the nth payment. The first payment is due 3 years after the loan is taken out. Calculate the amount of the drop payment. So first of all, we are given the discount rate and we will convert it into interest rate because we're more comfortable working with the interest rate. So the discount rate is 5.5%, and we know that I is equal to D over 1 minus D. So 5.5% divided by 1 minus 5.5%, that gives us 0.0582 as the corresponding interest rate. Now, the payments here are deferred because they are not happening right away. The first payment is due 3 years after the loan is taken out. Now, in such situations, one technique is to find the value of the loan 1 period before the first payment and take that point, the 1 period before the first payment, as the present time 0. And the payments start in this case at time 3. So we find the value of the loan at time 2, which is 1 period before time 3. And the reason for doing that is that way we can directly use our annuity immediate formula, because annuity immediate gives the value 1 period before the first payment. So the value of loan at time 2 will be 1. So the loan was 15 million. So at time 2, its value grows up to 15 million times 1.0582 square, because that's the interest rate. And so it's 1.68 million at time 2. And now for the rest of the problem, we treat time 2 as our usual present time. We can treat it as time 0 because now we have its value at time 2. So the n level payments of 1.2 million each. So therefore, by the present value formula of annuity immediate, the present value, remember now the present in our case is time 2, equals x times 1 minus 1 plus I to the negative n over I. And the present value now at time 2 is this one, the 1.68 million. Okay, so it's not 1.68 million, 16.8 million. That's what it was before also. So equals payment times 1 minus 1 plus 0.0582 to the negative n over 0.0582. So this gives us n equals 29.8, but that's the number of payments. So that tells us the regular payments are 29. And the 30th payment will be the drop payment. So let's call that as Y. So therefore, the present value of the loan, the present value of the 29 regular payments plus present value of the 30th payment. And again, remember, present in our case is now 2. So the loan is 16.8 million equals the present value of the 29 payments. We use the annuity immediate formula with 29 for the n plus the present value of the 30th payment. So that needs to be brought 30 periods back through multiplying it by 1.0582. 30th payment is the drop payment Y. So this equation gives us Y equals 959,497. That rounds to choice D.